So as we look at the surface of these planets, kind of going from the core of these planets, switching gears and looking at the surface of these planets, they tell a story. For instance, they look very different. There's the surface of Mercury, the surface of Venus. Of course, Earth's surface has just got all that water, liquid water. The surface of the moon looks very different than the surface of the Earth and the surface of Mars. We need to kind of explain what we're seeing, or else I guess what we're seeing, use that to explain the history of these planets. For instance, Mercury and our moon have a fair bit of cratering still visible. And just a little bit about impact craters. In general, it does not take much of a stone or a rock to impact a planet or moon to make a big old crater. In general, there are more smaller craters than larger ones. One of the things, and I don't have it on the slide, but the moon actually is, the moon, if you step on the moon, you're like stepping into kind of soot or ash left over from your barbecue. They call it regolith. It's like this powdered substance on the moon. And actually, it's thought that kind of that pulverizing of the surface of the moon, the rock like that, happened because of micrometeorites impacting it early on in the solar system's history. Okay, so impact craters, though, do we have them here on Earth? Sure we do. This is an example of a meteor impact site in Winslow, Arizona. And I haven't been here, but I hear it's really cool. But honestly, we don't see much cratering on the Earth because of the Earth has kind of resurfaced itself through a number of different ways, and we'll talk about that coming up. The moon, though, still has evidence of all sorts of impact craters. Now, both the moon and the Earth was hit a lot early on in our solar system's history. But again, the Earth has kind of either impact craters have eroded away or been resurfaced because of plate tectonics, and the moon not so much. The moon doesn't have the weathering processes that we're going to talk about here in a minute. But isn't this cool? This is a crater called Tycho, and it's one of the things that actually you can see the ejecta blanket of Tycho here from Earth if you're looking up at the moon. But oftentimes craters have this central peak, and they kind of have terraced sides like that. So volcanism, of course, would be associated with planets or, dare I say, moons that orbit planets. Volcanism is associated with a geologically active planet. So, and you figure if a volcano erupts and you have this lava that ends up kind of, resurfacing the planet. Okay. Another thing associated with modifying a planet's atmosphere would be this what we call outgassing, again, which is associated with a geologically active planet. Outgassing is kind of like the planet burping. So gases move from the interior of the planet out. Plate tectonics. This section is just talking about what things affect the Earth's surface, or in the case of outgassing, the Earth's atmosphere. Tectonics or plate tectonics can definitely resurface a planet. So just a little bit about, again, about convection cells moving those plates of the lithosphere. If we call this cell 1, cell 2, I know I maybe should have picked a different color, and cell 3, okay, notice then, of course, we have the Earth's core, it's hot down here, and so we have, of these 3 cells, we have movement up here. These 2 cells, cells 2 and 3, are actually moving up, and between them and cells 1 and 2, can you see where actually here, these 2 convection cells, between them we have material that's sinking. So if we kind of look, for instance, what happens between convection cells 2 and 3, notice that we have we have this what we call diverging situation. Plates are moving away from each other. And when plates are moving away from each other, we end up making valleys. Kind of got my things mixed up here. We end up making a valley. Okay, so this would be, and I think I'm going to show you the Great Red Sea here in a minute. And when two plates are coming together, like plates 1 and 2, and notice they're coming together because what's happening between these, where these cells, convection cells that are moving the plates are, is we have material falling down. And where these plates are coming together or converging, we end up with mountain ranges. And the example here I have is the Himalayans. The Himalayan mountain range would be actually created because it is where there are two major plates coming together or converging. Okay, the example of diverging plates creating a valley is here, the Red Sea. Okay. So famous, let's see if I can get this to pull up for me. A famous example of movement of plates over millions of years is this one where, historically, if you go back in time, you would see that the Earth's crust, or excuse me, the Earth's land masses were all kind of are congregated together in one big land mass. I've heard it called Pangea is when it was the big land mass, and then broke apart into the continents we know today. So again, this would be showing you plates moving that crust, the lithosphere, and then moving as those plates moved, they've relocated those land masses. And so you probably recognize this is North America, South America, and Africa. So another process we have here on Earth is we have water changing Earth's surface. So very famous example is we have the Colorado River has literally carved a line into these rocks here. So water has made its mark here, changing the surface of the Earth here. What's in the news lately, this is fall 2012, is the rover, one of the rovers, the new rover on Mars called Curiosity, actually has found evidence that that water once flowed on Mars, and because Curiosity sent back images of these like pebbles, like if you go to a river bed, you'll find these little rocks that have been eroded and they continue to be eroded, and that's one. So another way that Earth's surface has been changed over time are these ice sheets, and you probably heard about the ice sheets would extend from the poles and they would go towards the equator, and then they would retreat, and then they would do the same thing again. So over time we really have these features that were made by glaciers, movement of ice, and actually this valley is an example of it. It's amazing. We do have the resurfacing of Earth by simply wind. And here's an example of wind erosion. Another example of the Earth's surface being kind of changed is large bodies of water would relocate objects downstream. For example, we've had flooding here several years, bad flooding, and I bet you can picture that.